go from there.
Hey, Polly!
Okay, for everybody listening at home, hi, Polly. We are, I'm stalling going through the test until Monday, until everybody has taken the test.
Can you see our grades at the end of class?
They're not quite ready yet. I want to make sure I grade them all in one fell swoop when I'm in the same mood when I'm ready. So, but every once in a while, I do the partial credit thing where, oh, this seems like it's 4 out of 10. And then the next person says, oh, that's 6 out of 10. It's the exact same problem. That's awkward.
Yeah, that makes sense.
Number 19. Take out your notes, please. We are jumping a chapter. We're going to skip back to chapter 5 when we're done with this. But we're jumping ahead to chapter 6. This has a few things to know. Chapter 6 is a chapter called Conics. I'll explain in a moment. The first section of this is relatively notes intense. So there's good news and bad news for you. The bad news is you're getting lots and lots of notes in the last 2 days. The other one is that there will be no homework over the weekend. So, as long as, no problem. Stay tuned on the notes though. And be prepared to have your brain kind of flipped upside down by this chapter. It can be a little intense. I'll walk you through it. As a general rule, this chapter is one of the more intense ones of the year, which means I'm probably going to have homework every other day rather than every day. That does mean you're going to be swimming in notes. I mean, swimming. So if you are gone, be diligent and grab the notes of somebody else. Or if there's any confusion, come back to me. This is one where if you lose a lot of notes, you're, oh my goodness.
Polly, get out of that book.
Right. At your leisure when you're healthy. So, what are conics? Conics, first of all, if you could draw an oval, we're going to be calling it an ellipse, and then try your best to do the same size oval directly below it. We're going to make a 3D shape here. So oval, oval, try your best to make them same size, and then one directly atop the other. Do me a favor, go to the right edge of the top and crisscross it so that it hits the left edge of the bottom. And then do the same thing here. It kind of makes an hourglass. This is what we would call a double cone. It's a double cone. The top is a circle. We're looking at it from the edge, but it is circular. If you looked at it from straight down, it would look like a circle. And it has a radius like a circle. Now, why are we calling this conics? Picture that this is made out of something like clay or butter or something that you could cut relatively easily. If I were to take a very sharp knife or hot metal wire or something and cut, depending on which way I slice, I'm going to get different shapes. Use your imagination. What if I slice straight across? In other words, if I cut parallel to the base. Like if I'm sitting this double cone on my desk, this is a bad example, but it's slanty. But let's just say here, I don't know if you can see me, Paul, but here, if I've got a double cone, I actually had one at my previous school. I might have to go and buy one. Where it was made out of plastic and it had like green and yellow transparent thing. It was pretty cool. But can you imagine what sort of shape, like if I just take a knife and go chop, and then lift the thing up and look at the cut, what shape would the cut be?
Circle?
It's a circle. I will just draw a circle. If you cut it perpendicular to the base, you'll get a circular cut. What if you cut a little bit slanted? The word we're going to use is cut obliquely. is a word that means crooked or off center. Can anybody picture what shape you'd get then? If you just tilt it just a little bit. You'd get an oval. Yeah, we're going to call it an ellipse, but yeah, you're right. You get an ellipse, which looks like that. So can everyone kind of picture that? Okay. I need to draw another double cone just because I'm making a mess on this first one. Hopefully you got the hang of how to draw these. There are two more types of cuts I want to try. These are much harder to see visually, so you might have to just take my word for it. What would happen if I cut it straight up and down? In other words, if I cut perpendicular to the base. Do you see that it'll hit twice? It'll hit two different times. It'll look like this. I don't know if you've ever seen that shape before. It has a specific name. You may know what it is? I wasn't expecting, yeah.
Is it just a parabola? Like,
It's close. It's sort of a parabola. Parabolas actually curve inward, and this is actually going to flatten outward. So it's a sort of a cousin to the parabola. It's called a hyperbola. A hyperbola, which is, again, it's very closely related to the parabola, only there are two of them going in opposite directions. Hyperbolas always come in pairs. And they'll be opening in opposite directions. We'll talk more about hyperbolas a little later. There's one other, and it's very tricky, it's sort of like a trick shot here. If you carve, you have to be very careful to cut so that it's exactly, have you seen this in geometry? We have two arrows pointing the same way. Do you remember what that means? Yeah. I'm sorry?
isn't that parallel?
Parallel, correct. This, if you cut parallel to a slant edge. So any of these slanted edges, if you cut exactly parallel to it, you're going to get something that looks like this. Does that look familiar? It's a parabola. Parabola is actually one of the trickiest ones to get if you're trying to carve it just by hand. You have to be exactly perpendicular, or parallel rather, to one of the slant edges. Make sense of that? Now, on the test, the reason I'm talking about conics, conics is based on the word cone. And if basically if you slice up a double cone, you get these four shapes. Circle, ellipse, hyperbola, parabola. These are all called conics, right? And this is the topic of this chapter. So first is how to create them from physical objects. Like which way would you slice in order to get them? That'll be one of the test questions. So if I put it, made of soft cheese or something, but here's a double cone, how do you slice it so that you get a hyperbola or a parabola or an ellipse or a circle? If you can tell me that, you get that part of the test now. Okay? Now, once we start graphing these things, it gets a little intense. I'm going to give you the formula of the first one first. I had the chapter 6 homework guide sheet typed up 10 minutes ago, and I hit save. I literally hit save. And then the little spinny thing kept spinning, and everything went gray. And then I got an error saying, Microsoft Word has stopped working. Please blah, 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 blah. So I had to go to Control-Alt-Delete, shut down Microsoft Word because it was frozen, and it did not save. So, I hate Windows 10. I digress. But I will have that prepared for you. I have Windows 7 at home. I will type it up at home. I will try my best to get it to you. Okay, I feel better. But if you had a homework guide sheet, I was about to say look at homework 6A. You can't because it didn't get printed. 6A, we're skipping. We're skipping the very first section of the Conics section. Because the homework is a little esoteric and we don't need it. We're skipping straight to 6.2, which is on circles. Allow me to introduce you to the circle. Now, we know from past experience the four basic forms of a line: slope-intercept, standard, point-slope, intercept. And at this point, we know at least three forms of a parabola: vertex form, standard form, x-intercept form. The circle has a somewhat different formula, although you will find some of the letters familiar. Parentheses, x minus h, parentheses squared. That looks a little like a parabola. Plus, parentheses, y minus k, parentheses squared, equals r squared. That is the basic form of a circle. The reason this works, when you, if you remember this, like y equals x, can somebody tell me what shape that would be if you graphed it? Yeah, go for it.
Be like a diagonal line.
Yeah, it's a diagonal line. What about this? Parabola. It's curving. So instead of having a line, it's a line that bends, if you will. Now, you notice x is squared? It would have been a parabola, but they squared the y in addition to the x. So the x bends it this way, the y squared bends it this way. It sort of bends in on itself, and it circles out, literally in this case. So, there are, let's see which you remember from geometry. A circle, pretend that's a circle. It's a little lumpy. What do you call this special point? Don't work too hard. It's what?
The midpoint?
Midpoint would be in a segment. You're very close.
The
Starts with C.
center?
Center. We're going to use the letter capital C. I'll put it in stems to show it's capitalized. As the center, and that's h comma k. Last time we saw h comma k, it was for vertex form, for vertex. That's still true in parabolas, by the way. But h comma k get used for any special starting point. In this case, a circle, center. There are two things you need in order to define a circle in geometry. Am I out there? What two things do you need in order to be able to draw a circle properly? Yeah. A radius and a center. You need to know where the circle is and then how big it is. Oops. Sorry. Smooch my thing. A center, and then you need a radius. The radius is the distance from the center to the edge. Those are the only two things you need in order to make a circle. Center, radius. So, the radius is right here. Let me give you an example of what this looks like. If I gave you x minus 3, parentheses squared, plus y minus 1, parentheses squared, equals 25. Can anybody tell me what shape that would make if you graphed it? Sophie, what shape is that?
Circle?
It's a circle. Tell me why you know that.
Because it's x minus h and plus y minus k equals
R
squared.
squared. They all have to be squared, otherwise it's not a circle at all. It'd be a line. Make sense? So yeah, it fits the form for a circle. The x is squared and the y is squared, and they're added together. The basic thing that makes a circle is x squared plus y squared. Equals whatever, it'll make a circle. Equals some positive number. That gives you a circle, pretty much always. And you remember how we studied inputs and outputs? Input is left, right, up, down. Output is up, down. Input doesn't do what you expect, output does. This is going to disobey that just a little bit. We have run into this in weird problems. The question here is which letter is input, which letter is output. This is actually kind of an alien form. Both of these are input. Why would I say that? Just visually, what makes you think both of them are input? Yeah.
Because they're both being added together to make something else.
Right, and they're both being squared. They're both being kicked around by the problem, basically. Normally you plug an x in and the x gets kicked around, times it by 5, squared, subtracted 4. This, that, and the other thing, and y is just sitting there twiddling its thumbs waiting for an answer. This thing, on the other hand, is a little more exciting. Could I write this in y equals form? Yes, but it's totally messy. I'll show you that later. Can somebody tell me where the center of the circle is? Go, speak.
Would it be 3, 1?
It is 3, 1. It's a lot like point slope form. The minus sign is supposed to be there. It's like vertex form too. The minus sign is supposed to be there, so don't steal that. So it's not -3, -1. It's just plain old 3, 1. Can somebody tell me the radius? Careful there. Michael. What's that?
I guess it's 5.
5, correct. How do you get that?
25 is 5 squared.
Yeah, it's already squared, so you gotta take a radical 25. And it's fine. Let's graph this thing. Direct me. How on earth would I graph? Yeah.
Oh, I have a question.
Yeah, go for it.
What happens if you get a number that's like what happens if there was like a 27?
Oh, if it's an icky radical or something like that, you'd leave it as an icky radical. If it's radical 27, now that would actually reduce to 3 radical 3, but then that's all you'd write, 3 radical 3. Yeah, you might get an icky radius. That sometimes happens. It actually happens about more than half the time. But for now, we're just going to have nice ones. Eventually, we'll get some icky ones like radical 3. We'll see. Direct me. Yeah.
So you go over 3 up 1,
Yep. You go to the right 3 and up 1, and that's the what?
center,
Center.
and then you go over 5.
Yes. Over 5, which direction or directions?
It doesn't really matter as long as it's not diagonal.
Right. And what are the easiest directions to graph? Just physically, like we were doing. To measure it over.
Right and up.
Right and up and
Down and left.
and left and down. Exactly. I would not try to go 5 diagonally. That's tricky. But you can go, like this is 3, 1. I'm going to mark that there. Over 5 to the right. 5 to the left. 5 up. 5 down. 1, 2, 3, 4, 5. And then draw your best circle. If it looks like an egg, don't feel bad. That usually happens. The first few 100 times you draw a circle. Oh. Now, these are sometimes called the cardinal points, kind of like the cardinal directions on a map or north, south, east, west. So here, this is 3, 1. The points by which you graphed it are 3, let me see, 3, 6, 3, -4, I think. This is 8, 1, and this is -2, 1. So if you can spot those 4 cardinal points, you can graph. You're done. Does that make sense? don't worry if it's not a work. If it's not a work of art, that's pretty typical. I got really lucky drawing that one, by the way. Usually when I graph by hand, I have this bad habit of like the dashes going left, right. I make them bigger than the ones going up and down, and the whole thing will.
Oh yeah, that's what mine
So yeah, don't feel bad. That's in other words, drawing the plug. Now, let's see if you can do it backwards. If I give you a graph, can you give me the equation? The center is at negative 3, 4. Can you give me that circle's equation? Yeah.
You first start with like x plus 3 squared.
Yeah, yx plus 3.
Well, because it's negative.
Right. I'm just going to be persnickety and do x minus negative 3. Kind of like I do with point slope form. X minus negative 3 what?
Squared.
Squared. In other words, start the formula from beginning to end. X minus 3. Where is the center? Can you tell me? Like what comma what?
Negative 3,
Negative 3, 4. And by the way, these little stems, they're called serifs, by the way. The only reason I do a stem is to show it's capitalized. Quick question. Is this a capital C? Are you sure?
Now it
Is this a capital C?
is, yeah.
Yeah? Are you absolutely sure?
No.
In other words, there's no way to tell until you have something to indicate it. So, yes, I know, I'm teasing. But, is this a capital C?
Sure.
Yes.
It's in front of me.
There's beyond all doubt. Lowercase c's do not have the stems, the serifs. So, just so you know. I'm not trying to make horseshoes, in other words. My capital C's tend to look almost exactly like horseshoes because of slopping them up quickly. Somebody pick up where they left off. John. So x minus negative 3 squared, and then we'll keep going.
X minus 4 squared,
Another
plus.
Plus.
X minus 4 squared,
And then parentheses what?
or sorry, 1 minus 4 squared.
Y minus 4 parentheses squared, good, equals what? What's the radius? What's that?
Equals 4,
It equals 4. How do you get that?
radius is 2.
The radius is 2. You just count it over. This is really 2 squared. Ta-da. You're done. So at this point, if I gave you the equation of a circle, do you think you have a fighting chance of graphing it? And if I gave you a graph, do you think you'd have a fighting chance of getting the equation of a circle? Okay. Now, in this chapter, I have to introduce you to a piece of terminology. There are 2 words you're going to have showing up again and again and again. The phrase graph and analyze. Graph is pretty self-explanatory. Draw a picture. On an XY plane. So it is, what we've been doing forever. Analyze means find all relevant parts. That can get exciting in both senses of the word. It can get exciting in the sense of Christmas morning where you say, wow, this is actually a gift. I actually got it, or knocking a home run out of the park. That's exciting. Also, getting chased by a rabid tiger is exciting in the sense of being terrified. Both of these will probably show up at least once during the chapter. Let me tell you what you have in store. There are 4 types of conics. We're going to study them in this order. Circle, ellipses, hyperbolas, parabolas. Now, the number of analysis parts. How many analysis parts will there be? It's different for each shape. In other words, if I give you a circle, how many pieces do you have to worry about finding? Turns out there are 2. Anybody know? Yeah. Center and the radius. If you can find the center, something comma something, and the radius, you have fully analyzed the circle. I'm going to put parentheses 3 because there is something in the last section of the chapter. This includes something called eccentricity. That is going to sound really exotic. It should. And I'm not going to tell you what it is yet. You don't have to worry about it. Just, there is a third part. There's going to be one extra part for all of these. I want to include something called eccentricity, but I'm not going to do that till the end of the chapter. For now, as far as you're concerned, there are only two parts you ever have to worry about in a circle: the center and the radius. The ellipses, which we're going to be covering next week, there are 12 parts you will have to memorize. The good news is that most of them are related to each other. So once you know the first two or three, the other ones are really super easy to memorize. Hyperbolas.
Maybe do like 12 comma, or in parentheses 13, since you said add that?
Correct.
Okay.
Yeah. And the eccentricity was 13. Hyperbolas, there are 14 pieces of info, with 15 including the eccentricity. Parabolas, there are 5. 6 including the eccentricity. So just letting you know ahead of time. Ellipses and hyperbolas have bucket loads of things you need to cover when you're analyzing them. It's not as horrible as it sounds. For example, you see these 4 cardinal points, for example? For an ellipse, it would be like the top, the bottom, the left, and the right. That would be 4 of them. So there are other things, but I'll show you more on that Monday. I don't want to completely overload you. Circles, I will say, are the nicest ones to analyze. They're nice and short. There's not much to surprise you as far as what to look for, how to graph them, what to expect. So your job for the homework, which is not due today, Monday, it's due Tuesday, is to memorize the form of a circle, x minus h parentheses squared plus y minus k parentheses squared equals r squared. And be aware that there are 2 pieces, center and radius, how to graph it.
Like a homework?
Pretty much. Okay. Now, I want to brace you for a few curveballs. I like to think of it as a detective problem. Let's see how much geometry you remember. Example. A circle has a center of 3, 2, and is tangent to the y-axis. Give its equation. Go ahead and write that down first. We're going to explore this. They gave you the center of a circle, which is good. You got one of the 2 analysis points. You will have to find the other, the radius. They say it's tangent to the y-axis. Geometry people, what does it mean to be tangent to something? If you run a tangent line, how do you know it's a tangent line?
It's like barely touching. the
Right,
end of the
it's
circle.
barely touching. In other words, if you have a circle and you have a line that just barely touches once, this is a tangent point.
Okay, that's why when people go on tangents.
Yeah, it goes spinning out into space, exactly. Does anybody happen to remember the name of a line that hits twice? That's a very good idea. If it only goes from here to here, if it's just a line segment, that is a chord. The entire line that punches through and goes forever is called a secant line. So you can call this a tangent line. And there's a tangent point, and these are secant points, and this is a secant line. Make sense? The secant we're not really going to worry about just yet. Tangent I'm interested in for this problem. In other words, if something just barely grazes the graph, what would you suggest we do first in this problem? What would be a logical thing to do? Yeah. Find the center. In other words, do what with graph it. That's a very wise thing to do. Graph 3, 2, and let's see what we're talking about. Okay, good. 3, 2. And they say this is tangent to the y-axis. What does that mean? First of all, the circle is centered here. So I don't know how big it is. It might be a teeny weeny circle, it might be a huge circle, but it's centered, it's going to get larger, smaller, but it's centered around here. Any idea whatsoever how you find the radius of this thing? There's a big hint in there, if you can see it.
Y-axis?
What about the y-axis?
It's
Tangent to. Yeah, so in other words, it touches it how many times? Only once. It's going to hit here, which means it's going to look something like this. Can anybody see the radius? B. It's 3. Going down 2 doesn't get all the way to the edge. When I try, this on the other hand, goes right to the edge, and it's easy to measure. Going up, down, left, or right is easy to measure on a graph. Going diagonal is a pain in the neck to graph. Yeah. So.
how do you know that it was going to touch the y-axis?
Oh, they said it is tangent to the y-axis. That means it just grazes the y-axis. That's the only thing that told us. Can anybody give me the equation? Go, B.
So it'd be x minus 3 parentheses squared
X minus 3 parentheses squared
plus y minus 2 parentheses
plus
squared
y minus 2 parentheses squared.
equals 9.
Correct. Yeah. That make sense? This is sort of a detective problem where we had to find our own radius. But it worked. Yeah. Let's see how good you really are. Let's suppose I'm thinking of a circle. Yeah. Circle with the center of 6, 1. Oh wait, no, I take that back. 4, 1. And it hits the y-axis at, hang on a second, I'm going to do a little map here. Whoops. And y equals 4, and y equals -2. Find the equation. So, do this issue on your own. What would you do first? Definitely. Graph anything you have. 4, 1 is the most logical thing to start with. The center. Okay, graph. I'll try and make this mean 4, 1. Okay. Now what? Is there anything else we can graph?
You can grab 0, 4 and 0,
Exactly. These are y-axis hits, which we also call y-intercepts. This is 0, 4. And this is 0, -2. Okay, I'll graph those. Okay. Can anybody give an idea of where the circle is now? By the way, here's a refresher of first year algebra. Do you remember the quadrants? Quadrant 1, 2, 3, 4? Where they are? Jack, where's quadrant 1?
What?
Where's quadrant 1? The paper
The
zero.
test, I haven't been paying attention.
Oh, I'm an idiot, sorry. I'm sorry.
Oh, but
Just ignore me.
But
My bad.
quadrant 1 is the upper right one.
I'm sorry, thank you. Holy mackerel. I knew that, I did. Okay, Michael, take over. Where's quadrant 2? quadrant 3. This is quadrant 4. For first year algebra, those are the quadrants. The reason I ask that is I'm going to ask, the center is in which quadrant? Yeah, quadrant 1. It's up here. So, does this circle hit all 4 quadrants? Yeah, it does. Does it make sense that if I draw, I'm going to do a dotted line here and here, that these are both radii? There's from the center to the edge. It'll give you some idea of how to draw it. And it's a little flattened, but good enough. There's roughly your circle. I have the center already, it's 4, 1. I would like to find the radius. They didn't give me the radius. And if I go straight over, I have absolutely no idea how far that is, because they didn't tell me. This is a radius and this is a radius, I just don't know how long they are. Do you have any bright idea? No.
Maybe some like geometry.
Yeah, that's a good idea. What part of geometry?
Well, you know that the y-axis,
Uh-huh.
the distance between that is 6.
Ah, okay. So this distance is 6, correct?
And you know both the r's are equal. Well, maybe what you can do is you can just get the distance formula.
Okay.
Between like 0.4 and 4.
Good point. What's the distance formula?
I don't remember.
Okay,
It's like-
okay, fair enough. It's a big radical.
Yeah, the radical and like x minus x1.
Yeah, x2 minus x1,
Yeah, and then
parentheses,
y2 squared.
squared,
Y2 full minus plus
plus, which one?
plus
Plus.
y2 minus y1 squared.
Squared. That's the distance formula. The distance formula, I'll actually have a shorter version of the distance formula for you a little later. But for right now, this is the Pythagorean theorem. Turned inside out. Let me show you why. If I want to find the distance from this point to this point, and I'll mark these real fast, this is 0, 1, 4. Does it make sense that I could go to either one of these and it'll work? I could go down here and it'd do the same things I want up here for distance. So, from here to here, watch this. It's kind of sneaky. This is a right triangle. Any diagonal distance will drop a right triangle if you draw it. How big is this? Yeah, 3. It's just kind of 2, 3, 4. How long is this? 4. Does anybody remember geometry, people? There's a common right triangle. 3, 4, something. What's that? 3, 4, 5. Right. If you have that memorized, great. Let's pretend you don't. 3 squared plus 4 squared equals r squared. A squared plus b squared equals c squared, where c is the longest side, hypotenuse. Do this. 9 plus 16 equals r squared. This combines to make 25. And lo and behold, square root plus minus, I get r equals plus or minus 5, and one of those makes no sense when you're drawing pictures. Which one? Minus 5. There's no such thing as a radius of negative 5. A radius is a length. You gotta have that being positive. There's your final. Can anybody finish this problem for me? Do you have the center? Do you have the radius? Yeah, good.
So you would get x minus 4 parentheses squared.
Yep.
Y minus 1 parentheses 3 equals 25.
Equals 25, and that solves the problem. Did I ever teach geometry? Yeah, here, no. Because a certain somebody stole them from me, but I'm not bitter about it or anything. I'm not sure what's causing me.
No,
I
it's
guess
a-
whatever, but alright. Sometimes if I kick something, it works, but
You should have been like, oh, it's just you.
it's gone now, that's
Yeah.
what I'm saying.
You
Yeah.
picked it, yeah, it's gone.
Yeah, nice. Is this making sense? Again, circles are relatively comfy things to graph and to analyze. So I just want to give you one last thing. This is, and we're going to continue this on Monday. But what you do, this is going to look a little on the startling side, and I have to do a little mental calculation, which I hope works. I get in trouble when I try to do these in my head. You know what? I'm going to cheat. I'm not going to do it in my head. I'm going to do it on the computer. Why? Because I am famous for. Oh, there we go. I'm famous for doing things in my head, and the problem takes 20 minutes, and then the problem is impossible. I'm not going to do that to you. So, quick typo, not typo, type thingy. Alright, let's do this. Whoa. Alright. Yes, got it.
Mr. Carlson, do you want me to just put this in here?
Yes, please, just on top. Sounds good. Write this down, please. Example. If I may drag your attention to that. Write that down, please. On the test, you're going to get a question like this that says, graph and analyze. And that's all I'm going to tell you. When the time comes, I'm not even going to tell you what shape it is. It'll be one of the four shapes. I will give you a hint
Well, you
though.
don't know what shape this is?
Well,
Circle.
It is, because it's in the circle section. Is there anything physically in the formula that might give it away as being a circle? Because there's some extra stuff in there that doesn't seem to belong.
Probably the x squared.
Right. The x squared, the y squared, and the plus. That makes it a circle. If x and y are both squared, and they're both the same sign, so either both plus or both minus, that makes it a circle. As far as we know. As far as we know, there are no exceptions. You're not going to see an exception until probably the end of the chapter. Yeah.
Wait, is this like the quadratic formula of circles?
That's an interesting point.
Because
Is
like
there
I see A, B, and C.
is there I will, by the way, I will show you, this is a little early, I wasn't going to show this to you for another 3 sections, but why not? This is what we call a general form of a conic. If you find anything that fits that form, it is one of the 4 conics, guaranteed. This one actually fits the form. There's a couple missing terms, like there's no xy term, so guess what number is in front? 0, yeah. So this is 1x squared plus 0xy plus 1y squared plus 6x plus negative 8y plus negative 11 equals 0. So it is a conic.
We don't have to memorize that right now.
No. Yeah, for like 4 sections from now, we'll have that. For now, I just wanted to show you, you were talking about A, B, and C's. There is a formula that's based on these that looks a lot like the quadratic formula. It's actually smaller. But to be continued
Are we gonna be talking about comics for the rest of the year?
for the rest of the chapter. And then what- and then we'll-
Sections in the chapter.
Right.
I feel like I keep hearing you say comic.
Oh, conic, sorry.
Comic?
Conic, C-O-N-I-C, not comic as in haha.
Oh, comic.
So, I mean, there will be a few haha things, but probably unintentional. So, as far as we're concerned, if the x and y are both squared and they're both positive or both negative, you can be pretty much guaranteed it's a circle. The only exception is I'll show you about 4 sections or 5 seconds from now. Okay? There's a bit of a problem though. This is not in the form of a circle. Is there a way to cure this so that it is in the form of a circle? Yes, and as a matter of fact, although you've never done it in this style before, you know how to do it. Do me a favor. Segregate the x's and the y's. Not in the civil rights sense, but put them in separate parentheses. Equals, and then, yeah, there's one oddball in there, there's the negative 11, which doesn't seem to belong to anything. Please add the 11 to the other side, so you don't triple it. So I'm going to put it over here. This should remind you of something. Can you list off all the x terms in order? Sophie, help me out here. Just any x terms, put them in order of highest to lowest power.
X squared.
Plus 6x. And do me a favor, plus blank.
Are we do minus? Or do we do plus?
Because this is plus.
Oh, okay.
Now how about over here? Julia. Or, sorry, no. Do the y's in order.
Y squared.
Julia, you have a bass voice, I didn't realize. Go ahead.
Y squared plus negative 51.
Yeah, and I'd like you to do plus blank. We've seen something like this before in a technique called complete the square. 5 steps. Set equals 0, blah, blah, blah. And believe it or not, this is actually easier than the complete the square you did last year. Can anybody tell me what binomial squared conic does? It's got to be square the first, double the product, square the last. So what was this? Yeah, it's x plus 3. Did I see that? What should this have been? 9. How do you get that?
3 squared?
Yeah, square the last. Now there's extra weight here. Perfectly legal as long as you do it to both sides. Add a 9 on the other side. Does that make sense? Keep it balanced. Can anybody tell me, plus, what binomial squared did this come from? Feel free to use a minus if you need to. Julia Sushan. I'll do y squared minus 8y just for old times. Yeah. Where do you get the 4 from?
Ooh, boy.
Usually there. Yeah, this is a double product, so you undouble it. You take half of the middle number. So what number should this have been? 16. You can do that as long as you do it too. Somebody add these up for me.
36?
36. That's in circular form. With one exception. Change this to a minus legally. So it's x minus what?
Negative 3.
Negative 3 squared plus y minus 4 parentheses squared equals 36. Somebody tell me where the center is. We have like a minute left. What comma what? What is that? 8. Almost. Negative 3 comma 4. Anybody tell me the radius? Yeah, Jack Lau. Go for it. What's the radius of this thing?
I don't know.
Okay. John.
I didn't,
Oh,
I wasn't.
Radius is 6. I don't blame you. Don't worry. So this is r squared.
Oh.
That is all you need. You have just analyzed your circle. All you have to do is graph it and you're done. That is largely all you need for the circle. So on Monday, I'm actually going to give you a get a large amount of time to do it if you work in class. We'll just top off and refresh your memory so you don't do a brain dump over the weekend. And, I think that's it. Please stand.
It's not like we wanted to be done with class.
All right.
It's just, we want to go all our class on Friday.
Dude, understood. Let's pray. In the name of the Father, and of the Son, and of the Holy Spirit. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. All right, see y'all later, and I will